Unit 15, Sampling Methods and Estimation of Sample Size. Contents: 15.1 Introduction, 15.2 Sampling, 15.3 Classification of Sampling Methods, 15.4 Sample Size, 15.5 Conclusion. Learning objective: it is expected that after reading Unit 12, you would be able to define what is sampling, classify sampling methods, calculate sample size. 15.1 Introduction. Unit 15 deals with the procedure of sampling that help you to arrive at a subset of the universe of your research. It discusses the various methods of sampling and tells you how to work out a sample size. You will again read about sampling in block 6. This is a subject you will need to master carefully, as no matter what type of research you wish to carry out, you will need to apply your skill on the crafting of sampling. 15.2 Sampling. A sample is a subset of the population that represent the entire group. When the population or universe is too large for the researchers to survey all its members because of its cost, the number of personnel to be employed, or the time constraint, a small carefully chosen sample is extracted to represent the whole. See figure 15.1. The sample as drawn in figure 15.1 is expected to reflect the characteristics of the population. A well-selected sample may provide superior result. For example, in research where well-trained interviewers are required, it may be possible to get a few trained interviewers to collect the sample rather than to get many trained interviewers to investigate the entire population. The trained interviewers may gather better quality information than non-trained or less trained interviewers. By contrast, if the population is sufficiently small, the entire population should be studied. When data are gathered on each and every member of the population, the study is known as census study. The researcher is expected to clearly define the target population. Quantitative and survey methods. This is the population, the full characteristics, the parameters, population characteristics. Parameters, measures describing population characteristics. So samples, some small portions only taken, sample characteristics. So here the statistics, measures describing sample characteristics. So statistics estimates the parameters. So relationship between population parameter and sample and statistics. A population may be defined as an aggregate of individual possessing common traits or traits. There are two important factors. First, that a population is the complete group about which knowledge is sought. And second, each and every individual has some certain specific attribute or attributes. Let us now complete the reflections and action 15.1. Reflection and action 15.1. Work out the relationship between population, parameters, sample, and statistics to reflect the characteristic of the population of the unit of your research project. 15.3 Classification of sampling methods. Sampling methods are classified into probability or non-probability. If the purpose of research is to draw conclusions or make predictions affecting the population as a whole, as most research usually is, then one must use probability sampling. But if one is only interested in exploring how a small group, perhaps even a representative group, is doing for purposes of illustrations or explanation, then one may use non-probability sampling. Let us first discuss the probability sampling. A. Probability sampling. In probability sampling, each member of the population has a non-zero probability of being selected. The key point behind all probabilistic sampling approaches is random selection. The advantage of probability sampling is that sampling error can be calculated, which is the degree to which a sample might differ from the population. Probability methods include random sampling, systematic sampling, and stratified samplings. We shall discuss each of them. Random sampling. is the purest form of probability sampling. Each member of the population has an equal and known chance of being selected. The prerequisite for a random sample is that each and every item of the universe has to be identified. Random sampling is effective in a clearly defined population that is relatively small and self-contained. When the population is large, it is often difficult or impossible to identify each and every member, so the assemblage of available subjects becomes best. One obtains a list of all residents of voters list or telephone directory, then selects a sample using a sequence of numbers from a random number table. Random number can also be created in numerous computer softwares. See figure 15.2 that illustrates the selection of sampling using random number table. So this is the population. Randomly we picked up a few samples in the dark color, so using the random number table. So population simple random sample drawn, so dark color using random number table. Source Fisher, R, A and F, Yates 1982, statistical tables, Longman, New York. So this is the random sampling. Now we will look into the B, systematic sampling, is also called as the nth name selection technique. After the required sample size has been calculated, every nth record is selected from a list of population members as long as the list does not contain any hidden order. This sampling method is as good as the random sampling method. Its only advantage over the random sampling technique is simplicity. Systematic sampling is frequently used to select a specified number of records from a computer file. In figure 15.3, you can find elucidation of the systematic random sampling method. The first number 2 has been selected by random numbers, followed by the selection of every fifth item in the series. So quantitative and the survey methods, okay. 2, then after every 6, okay, sixth member has been selected. So this is a systematic random sample drawn dark color. So the 15.3, figure 15.3 is a systematic random sampling method. In C, stratified sampling is a commonly used probability method that is superior to random sampling because it reduces the sampling error. A stratum is a subset of the population that shares at least one common characteristic. Examples of strata might be males and females, or managers or non-managers. The researcher first identifies the relevant strata and their actual representation in the population. Random sampling is then used to select a sufficient number of subjects from each stratum. Sufficient refers to a sample size large enough for the researchers to be reasonably confident that the stratum represents the population. Stratified sampling is most successful when the within variance of each stratum is less than the overall variance of the population. When the strata in the populations are of equal size, unequal size, or having unequal incidence, and third, when the sampling is cheaper in the strata. Figure 15.4 shows the stratified random sampling method. Samples from the 3 strata have been extracted in proportions to their numbers. So this is a population and stratified random sample drawn. So in between this, okay, from that randomly selected. Okay, then fourth one is cluster random sampling is useful when the population is dispersed across a wide geographical region. This method allows one to divide the population into clusters and then select the clusters at random. Thereafter, one can either study all the members of the selected clusters or again take random or simple or systematic samples of this samples clusters. If the later system is followed, it is called multi-stage sampling. This method, for example, could be effective to study a tribal group or a community that is dispersed. The village could be used as clusters and can be randomly selected. Figure 15.5 shows that of 5 blocks, 2, 7, 10 and 14. Out of 16 has been selected by random number. Each block contains a series of samples as illustrated. So this population and cluster has been taken and drawn. So 15.5 cluster random sampling method. Now reflections and actions 15.2. Following the figures in the text, make figures based on the population pertaining to your research project that you selected while computing. Research and analysis R&A. Reflection and action. 13.1 and 13.2 show population simple random sample drawn in dark color using random number table. Systematic random sampling method, stratified random sampling method, and cluster random sampling method. B. Non-probability sampling. In non-probability sampling, members are selected from the population in some non-random manner. In this method, the degree to which the samples differs from the population remains unknown. Non-probability methods include convenience sampling, judgment sampling, quota sampling, snowball sampling. Let us now discuss each of the non-probability sampling methods. So first, convenience sampling is used in exploratory research where the investigator is interested in getting an inexpensive approximation of the fact. As the name implies, the sample is selected because it is convenient, also called haphazard or accidental. This method is based on using people who are a captive audience, just happen to be walking by, or show special interest in research. The use of volunteers is an example of convenience sampling. This method is often used during preliminary research efforts to get a gross estimate of the result without incurring the cost or time required to select a random sample. Judgment sampling is a common non-probability method. The researcher selects the sample based in judgment. This is used as an extension of convenience sampling. For example, a researcher may be decided to draw the entire sample from one representative village, even though the population may be distributed over a number of villages. When using this method, the researchers feel that the chosen sample is representative of the entire population. C is purposive sample. Much similar to judgment sampling, is where the researchers target a group of people believed to be a typical or average, or a group specially picked out for some unique purpose. The researchers never knows if the sample is representative of the population, and this method is largely limited to exploratory research. D is quota sampling, is the non-probability equivalent of stratified sampling. Like stratified sampling, the researcher first identifies the strata and then their proportions in the population. Then convenience or judgment sampling is to select the required number of subjects from each stratum. The researcher resorts to the haphazard or accidental sampling and makes no effort to contact people who are difficult to reach. This differs from stratified sampling, where the strata are filled by random sampling. Snowball sampling is a special non-probability method used when desired sample characteristic is rare. It may be extremely difficult or cost prohibitive to locate respondents in those situations. Snowball sampling relies on reference from the initial subjects to generate additional subjects. In other words, snowball sampling comprises identification of respondents who in turn refer researchers to other respondents. This techniques provides a number to access relative, invisible, and vulnerable social groups. While these techniques can dramatically lower the research cost, it comes at the expense of introducing bias, because the technique itself reduces the likelihood of that the sample will be represent a good cross-section of the population. For example, an investigator finds a rare genetic trait in a person and starts tracing his pedigree to understand the origin, inheritance, and etiology of the disease. You may have heard that only quantitative research requires sampling. The fact is that qualitative researchers use sampling procedures. See box number 15.1. 15.1 Use of sampling in qualitative research. As Berger and Sandcoats has pointed out, it is fairly common for qualitative researchers to use sampling procedure in the following manner. Sampling is a relatively small dealing with the typical cases. Use of flexible samples in size not requiring statistical calculation. Use of purposive sampling dealing with the non-probability. Use of sampling to achieve a suitability rather than representativeness. Sampling occurs while the researcher is in progress rather than selecting sample before starting it. We would now focus on procedures of calculating the sample size. 15 point for sample size. A prudent choice of sample size for a particular survey involves many considerations, among which are the resources in manpower, cost per sample units and funds available, the number and the type of parameters to be estimated. Obviously, this is specify will vary from one survey to another. All the same, a framework can be constructed within which general and variable decisions with respect to a sample can be taken. Sampling theory aids in arriving at good estimates of the sample size. The standard error here provides the key. Apart from the size of the universe, the sample size may depend on the following conditions. 1. The confidence limit set up for estimation. The heterogeneity of the population. And the third is the frequency or proportions of the triad attribute to be examined. The estimations of sample size also differs according to the purpose or the parameters under investigation. For example, whether the sample size is being estimated for calculating mean or proportions or for comparing means. For illustration, let us consider in box 15.2 and 15.3 the two cases, namely the estimations of the mean of normally distributed variable and the estimation of proportion. In these cases, there are two assumptions. Firstly, the sampling is simple, random and without replacement, and second, the population sampled is infinitely large. Box number 15.2, case 1. The sample size when estimating mean. It is known that the standard error of mean can be calculated from the following formula. Standard error is equal to delta by Vn, where C is the standard error of the mean, or is the standard deviation, and N is the sample size. Thus, one can calculate sample size using the formula following equation derived from equation number 1. So, N is equal to So sample size can be calculated using the following steps. Step 1. One requires to standard deviations of the universe which is unknown. A rough estimate of this measure, however, is sufficient for suggesting sample size. In many instances, the experience with similar problems will be good guide for making this estimate of the standard deviation. In other instances, an exploratory sample study of a small scale be conducted in order to arrive at an estimate of the variation. They estimate the standard variation of the universe. The range of the values in the universe may be estimated and used as guide. It is known that in normal distributions, the range is about 6 times that of standard deviation. For practical purposes, an estimated of somewhere around 1/5 of the estimated range is often used. Suppose the range is roughly 300, then that is the difference between the lowest value in the universe and the highest value is 300. 1/5 of this rough estimate is 60. Therefore, one may take 60 as a rough approximation of variation. So, step 2, it must be decided how precise the one wants the future sampling estimate to be. Thus, one may state that the estimate of true mean is sufficiently precise if confidence limits of 12 are attached to it. Such an answer might be practical for this particular problem. Step number 3. In this step, the researcher has to decide the confidence limit. He may wish to almost certain or be satisfied with saying a 95 degree of confidence, and the specified limit will contain true mean. The degree of confidence decided upon make it possible to translate the interval decides upon in step number 2 into standard error. If one is to be practically certain that the true mean will lie within the interval of plus or minus 12 around the sample mean, then the interval of plus or minus 12 becomes plus or minus SC, or SC is equal to 4. If on the other hand one is willing to settle for 95 degree of confidence, then plus or minus 12 become plus or minus 2. Standard deviation and is equal to 6 plus or minus 2 standard equations. And so using equation 2, the sample size for the above example will be case 1. At the level of practical certainty, sample size is 60 by 4 all square, that is 225. Case 2, at the stage at 95% confidence limits, sample is 60 by 6 all square, that is 100. In case of S1, SE is 4, whereas in case of 2, the SE is 6. So thus in the above example, the sample size should be somewhere around 225 if one wishes to be practically certain that true mean will be lie within an interval of plus or minus 12. But the sample needs contain only 100 items of, if one settles for a 95 degree of confidence, then that true mean will lie within an interval of plus or minus 12. Sometimes the acceptable difference between the sample and its true mean is expressed in percentage rather than absolute. For as an example, plus or minus 12 in step 2 of the above examination example. Suppose the expected mean is around 500, then the acceptable interval would be plus or minus 15. But this necessitates an approximate knowledge of the expected mean. Box number 15.3, case 2. Sample size when sampling for proposition. Considering the estimation of the proportion of individual in a population with some particular attribute of example, those who own tractors or agriculture. This portion, though not precisely known to be investigator, is generally known to him to an order of magnitude at least. That is to say, he will often know that owning tractors is quite rare, saying then 3 is 100%, somewhere infrequent. 3 is 100 in 100 to 3 in 1000 persons, fairly common. 3 in 10 or 3 in 100 or very common, more than 3 in 10. If owning tractors is known to be more infrequent than 3 in 100, a simple random sampling would invariably be much more too inefficient, and the other sampling methods appropriate to the estimation of rare events should be used. To assume random sampling abounds to be assumed that the investigators' interest centers on only those attributes, those frequencies are at least 3 in 100. Even within these limits, it is clear that if the population proportions is to be known exactly, the entire proportion must be examined. This is impracticable and generally unnecessary. For the investigator usually does not require this degree of exactness. His requirements are related, of course, to the use to which the estimates is to be put, and thus may be vary from one investigator to another and with a proportion itself. So it is known that the standard error of a proportion can be calculated from the following formula. Standard error is equal to V into PQ by N. So whereas standard error is standard error of proportion, P is the proportion of an attribute in the population, and Q is equal to 1 minus P, and in N is the sample size. Thus one can calculate the sample size N using the following equation derived from the equation 4. N is equal to PQ by S standard error whole square. The sample size can be calculated using the following steps. Step 1. One required to estimate of P from which Q follows, which is of course unknown. A rough estimate of this measure, however, is insufficient for suggesting sample size. In many instances, experience with similar problems will be good guide for making this estimate of the proportion. In other instances, an exploratory sample study on a small scale can be conducted in order to arrive at an estimate of proportion. If, however, neither of these two approaches is possible, then one can conservatively assume that P is equal to 50%, which leads to a large sample size than any other value of P. This is because 50% less 50% breakup The numerator PQ in the formula in the equation is 5. N is equal to PQ by C square is the largest. However, for the following example, let us consider that P is 30% or 0.3. It must be decided in step 2. It must be decided on how much precise one wants to sampling estimate to be. The researchers may be considering an interval of say plus or minus 6% around a sample population as satisfactory in this situation. In this step, the researcher has to decide the confidence limit. He may wish to be almost certain or to be satisfied with say 95% of confidence that the specified limit will contain the true mean. In the former case, plus or minus 6 degree will be equal to 3 plus or minus 3s and consequently standard error is equal to plus or minus 2%, whereas in the case of later case, plus or minus 6% will be equal to plus or minus 2 SE and SE is P is equal to plus or minus 3%. Using equation for the sample sizing for the above example will be case 1. At the level of practical certainty, the sample size is 525. At the level of 95% confidence limit, sample size is, here the size is calculated as to become 233. So the use of formula to obtain an estimate of sample size does not give us more than a rough approximation. In practice, it is advisable to have to take a sample size estimate as a bare minimum to be increased for safety. Let us now complete the reflections and actions 15.3. Reflections and action 15.3. Suppose in your research project you wish to estimate the sample size for calculating mean, and the assumption is that sampling is simple and the population sample is infinitely large. Further, you are in the stage of taking the 3 steps as elaborated in case 1. Give the text. The exercise for you is to work out in detail each step and write it down in the fashion given just after box 15.2. 15.5 Conclusion. Unit 15 discusses the importance of subject of sampling and provided you with relevant information on different methods of sampling. Further, it brought to us to you like the skill of calculating the sample size. You may like to keep in mind that Michael which said about sampling theory in statistics that it devotes itself to providing numerical estimates of the likelihood of that population value be within some defined range of that estimated for the sample, provided that the sample has been chosen in such a way as to meet the mathematical conditions to justify the computation of the probabilities concerned. Further, he clarified about another type of interference that is deserved while using quantitative data to support theoretical interpretations, and said the sophistication and elaboration for choosing a representative sample in this restricted sense has been overshadows the other kind of inference involved with analytical system. Statements are made for associations uncovered in a statistical sample. This is the inference that the theoretical relationship among conceptual defined elements in the sample will also apply in the parent population. The basics of an inference of this sort is the congruency of the theoretical argument linking the elements in an intangible way rather than the statistical representativeness of the sample. Further reading is from R.G. Burgess, Field Research is a Source and Field Marshal, and Dyson and K. 1917, Sociological Methods, a Source Book. Okay, this is the end of Unit 15. Thank you very much.